start to search for an element in an array. Fine, is simply like if you are given an array and like there is an array of 5 students, right? Sorry, simply take it that we have an array in which we have stored your marks of for end semester, so mid semester, and I want to see how many of students have scored say 25 out of 25. Fine. So I have an array of size 78. In that 78, I want to search a particular number that is 25. Fine. So what do you think? What the simple way to search for that value? What do you think? What will be the simple way? See, it's very simple that we have an array of elements, right? What do very simple approach say? Okay, first I'll go at index 0, look whether I find my value or not. If not, then I'll go to next element, then I go to next element, then I go to next element. Suppose it is like I want to find how many have scored. Let me reframe my question. The question is, if I want to find, has any student scored 25 out of 25? So I am in this array of 78. I'll just want to search whether at any value 25 value is present or not. I just am interested in finding whether the value is present or not. Fine. If I'm looking, that is a search question that we technically define. That is such thing is a search question, that you have a particular value and you have an array of elements and you want whether that particular element is present in that array or not. Fine. So to look for such problem is called searching a value in an array. Fine. And the simplest thing a normal human mind can think, that you will have a list of marks, that is you have a list of arrays, list of marks of array, yes, in form of array now. You will search at the first index value. If found here only, then you will say, okay, you find the value. Simple. If you didn't find the value here, you will go to next index value. You will look for value here. If you find it here, you will say, okay, finally, now I find the value. And in case, even if it was not present there, you will go to next index value, so on and so forth. Fine. That way, up to the last element you will search, last element of the array. Even if it was not found there, it was not found in any of these elements, then you will say this value is not present in this array. Fine. And in case if you find it at any of these locations, you will just say, okay, you find that value at this particular index value in that array. Fine. That is how we define the search problem in the array. Simple. Fine. And how you are searching that value in this array, what approach you are following. Based on that approach, we are given two methods, or we call them two methods of search. One is called linear search and another one is called binary search, that we'll be covering in today's lecture. Fine. And linear search is just this approach which we have discussed right away, that you will start at the 0th index. You will search whether the element is found or not. If the element is found, that's it. Your work is done. You will quit. You need not to search further because your element is found. But if it is not found at 0th index, then you will go to index 1 and search the element there. If you find it there, that's perfect. You will just say you find the element at index 1 and you are done. You will not search further. But in case you don't find it even here, then you will go to next and so on and so forth. And if you reach up to the last element of the array, and even there you didn't find the array, the search element, you will print the element is not present in this array. Fine. That's simple. This simple approach is named as linear search. Right? The simple approach is named as linear search. Now let's see the simple code for the linear search. Let's quickly just go to the logic. See, in this function, in this program, that's a simple program for the linear search. There we have just included a header file and we have our main function. In main function, we defined an array of integer array of size 5 with the name array itself. Right? And we also declared an integer variable I key and found to be equal to set to 0. Fine. Key is the variable we will be using to put the value that we are searching in the array. Fine. Now, here we have just done nothing. We have asked user to enter the elements of array. We know this code. Fine. So with this, as the array was created of size 5, suppose user has placed 5 integer values, let's say 10, 2, 5, 3, 1. Right? Those 5 values the user has entered in through this line of code. Fine. Now we ask user to enter the element he wants to search, and we are placing that element in array in variable key. We have a variable key. Let's say the user has entered value 5. User want to find whether the value 5 is present in this array or not, right? So what do we simply do? As we discussed, we'll look at index 0, index 2 up to last index. So we'll run a loop from index 0 to last index, right? And what do we do in this? We'll just check whether the key value is equal to the value at that particular index, the value of array element at that particular index. If it is present, as we discussed, if it was present here, we'll just print key, okay, it is found, and we'll go out. Fine. So to print that okay element is found, we set a variable found equal to 1. Initially we set found to be 0. Fine. Because if this loop was ever executed, it will set found to be 1 and break. What break keywords do? We have already discussed it. Break is a keyword. What does it do?
It breaks the system outside of the loop.
Yes, as the break keyword is executed, that's very good. It will go out of that loop. Fine. So as any element is found, loop will go out. That means it won't search for on next index values. Fine. That's simple.
Ma'am, I had a question.
Just a second. Let me just finish, then I'll take your question. Fine. Next, similarly, so this is just the logic we discussed. At index value 0, it will search. If it was found at 0 only, it will execute break and it will go out. It won't search further. Like for the value 5 at index 0, it is not found. Then I is incremented. I is set to 1. At index value 1, that is here, it will search key, that is 5 is equal to 2. No. So this part won't be executed. Fine. Again, I is incremented. I is set to 2 this time, and it will check key, that is 5 is equal to this value, that is 5. Yes. Then found will be set 1 and break will be executed. Right? As break executes, control will come to this line of code. And with this, you notice that these two values were never checked to be equal to the searched value that is in the variable key. Okay. Now, as the control comes here, it will say found is equal to 1. Yes. So it will print element is present in array at position. Instead of index value, we are printing position, that is first position, second position. So we are printing I plus 1. If you want to print just the index value, just print I. Right? We understand that logically. Else, print element is not found in array. You just need to pay attention why we use found. Just that there are various ways of doing this code. You may also write here only printf element is found and exit. Fine. If not that way, or you can use this way. There are various ways you can code it. Using exit also you can code the same logic. Just you need to play a little bit more. Fine. Now, any query on this?
Ma'am, I actually have 2 questions.
You have?
2 questions.
Go ahead.
Okay, so the first thing, if the array, if the person who's giving the data to the array, if they give, for example, if they fill up 10, 5, 5, 3, 1, so if they fill like one number twice, and if when we do a linear search for that based on the syntax that you've provided, will
Right.
it finally give us the position of the first five, the second five, or what will it do?
It will give you the position of, in this particular code, it will give you the position of first five.
Oh, right,
Because
because it'll break. It'll
it
break from
will
the loop.
find the first five and it will break.
Oh, okay.
Right? It depends
Right.
on the application what you are using. Accordingly, we can code and decode it. We can manipulate the code. But technically, logic is this one. Right?
Okay. And another question is that can when you use found equals 0 and then found equals 1, why can't we use Boolean?
Yeah, we can use Boolean too. It depends. Whatever. You can use Boolean, and even if you use exit here, just print line here and use exit. In that case, even we need not, you can code this same program in a way that you need not to have a variable found. Right? Instead of setting here found to be 1, you here itself print element is found at index value this. Instead of break, use exit.
Okay.
Right? Well, use exit. That means if element would be found, it will print and exit the code. Or else here, instead of writing this, you just write a printf statement instead of this all part of code. You just write a printf statement, element is not found. Because only the control will come to this line of code in this second reframing of the code. Control will come to this line of code only in the case it was not encountered exit here. Then
Right.
come here. So you can code it this way. Am I clear?
Yes, ma'am.
Okay. Anybody else have a query? All good? Okay.
Ma'am, there's a question in the comments.
Okay, let me see. Out of loop, ma'am, if there is. If we have to input array size also in this program. I will come to input array size. There are various ways to encounter input array size. The core logic says when the core logic is when we are talking about when we talk about the core logics of C language, it doesn't allow you to have a variable size of array. That means when you surf through various programs, you do encounter a problem like, okay, int n, you ask the user to enter the size of array and user enters the value in n variable and you declare then an array of particular size, that one, right? In the core logics of C, that is not allowed. Core logics of C. However, you see in many of your this online compilers, they allow this because they have they have manipulated the semantic rules of the C compiler in that way that it allows this way. But ideally, when we want user to specify the size of array, for that ideally we should do is dynamically allocate memory of that size. That we'll be discussing tomorrow. Right? Precisely it should be done that way, but how we do it, we'll be discussing that tomorrow. Right? Today we want to stick to this part. Okay? Any other query?
Ma'am, is it necessary to include the break statement in linear search?
Not necessarily, dear. Just look here. The second way I coded it, just let me do it with a different pen. The second way, the first way I have coded it, in that approach you have to use break. Fine? Because if you don't use break, it is fine that you don't use break. Even if you don't use break, even that case it will work. But why that will change logic? Pay attention. That's very good question. Everyone, please pay attention. Is it necessary in this code, what we have written here as of now? Let me just redo it. In this code, is it necessary to have break keyword here? Will the code work fine if we don't use break? How many of you say the answer to this query is yes? The question is, will this code work very fine if we don't use break, that simply means if we comment this break line of code,
It should work fine, ma'am.
very good. Anybody else? Yes, the answer is yes. In this case, it will work fine. It will work, it will print you. If the element is present, it will print you the element is present. It will print you if the element is not present, it will print you the same right answer. But just pay attention. That is very good question, because I don't want to go, didn't thought to go in the complexity.
But without using break, we cannot print the position.
Without using break?
We'll not be able to print the position because the value of I will move till the end.
Yeah. We won't be, that's very another correct answer. That's very correct answer, dear. If you are not using, if we comment on break, we will be able to tell ki yes, the element is present or not, but I will be incremented in the loop and I will always be printing value 5 in that case, because loop array will be ending at that very place. This is one reason. And second more technical conceptual reason behind this using break is, let me tell you this. See, this is at index 0, I'm just writing the index value. Index 1, index 2, index 3, index 4, right? And whatever values less we entered, 7, 10, 5, 3, 2. Fine? Fine. Now just look at the same code with the perception that if we are searching for a value 5, that is, the user want to search for value 5. He has entered 5 in variable k. Then to search for value 5, first we will search this element, not found. This comparison operation will be performed. Then we'll search this element. This comparison operation is performed for this value. Then we perform this element, look for this, search for this index value, and this comparison operation is performed. And once it is found and we use break, that's it. We need not going this loop next times. Fine. So technically, we are running this loop 3 times. We are running the body. You understand that? In this particular case, we'll be running this body of loop 3 times only. Fine. But second case, our second case is when we have put a comment on the break. Second case. In that second case, irrespective of we have found the element or not, then we'll be also going to next index value, comparing the value. Then we'll be going next index value and comparing the value. Fine. In the second case, when we have commented on break, we'll be executing this body of the loop 5 times. Am I clear at this point? This is very important to understand. You got the difference? If we are using break for this particular situation, when the value 5 is at index value 2, we'll be executing body of for loop 3 times. But if we comment on this break, we want to keep on searching, then your answer will be printed. Even if you don't want to print index value, in that case, answer will be printed. You just want to print that the element is found or element is not found. It will print the right thing. Maybe not the right index value, but it will tell you correctly the element was present or not present, right? But second, more conceptual logic behind the using break is that if you don't use break, this body of the loop will search for all index values, irrespective of your element was found here, 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 whichever index value. And so your loop will execute 5 times. Fine? Fine. So in algorithms, just I'll give you a very brief of this. In algorithms or in whatever these logics, it's basically in search algorithm. Algorithm is like you're telling an approach, how to search for a value. In these approaches, it is very important. The concept is time complexity. Time complexity is, in simple terms, don't go on technical definitions for now. In simple terms, time complexity is, okay, how long your code is running for a particular situation and what results if it is giving good results, fine. That is the first thing. The algorithm should work in the right way, should print the right output. But second thing is time complexity. Time complexity says how much time it is taking. How much time it is taking. You see, of course, if we execute this loop 5 times, it will be taking more time. And once we execute this code only 3 times, that will be taking much less time. Am I clear with this? Fine. Of course, if you run it 3 times, means these lines of code you are running only 3 times, this operation you are performing only 3 times. While you are executing it 5 times, you will be executing this line of code 5 times. Fine. Actually, if we don't use this break, we technically represent it with big O, then the complexity of this algorithm will be big O of n. I'll tell you what n is. But if we use this break, then in that case, the time complexity, even in that case, we will say time complexity is big O of n. But for this particular situation, it will be like big O of 3. And in this particular situation, you may assume it is to be big O of 5. Fine? Fine. That means to get the same results, you will be running this loop 5 times. And to get the same results, if you use break, you will be running this loop only 3 times. So in those terms, you will be more saving time. Time efficient. You are making this code to be more time efficient. Am I clear? Am I clear? Sure? Any query till this point?
Ma'am, if 5 is occurring more than once in the array, then what would the compiler have printed in that case?
Yeah, in that case, see, if for this particular code, suppose even 5 was here, right? Even 5 was here. For this particular code, we haven't commented on break. In that particular code, this will print once the 5 is found, the concept is clear. We just want to search is the concept. We are not searching how many copies of that is there. We are just searching that value is present or not. Pay attention to my question. I reframed my question. That my question was, suppose if I have an array of your mid-semester marks and I just want to find whether any student has scored 25 marks or not. Is there any student who has scored 25 marks? This is my question. For that question, it is a proper search question that you want some particular value to be present in array or not. Fine. You are not concerned about the number of occurrences of that question. Fine. If I just say, is there any student who has scored 25 marks? This is the query. Then that query you can frame as like linear search problem. That problem is like a linear search problem. That you just concern about whether a given value is present in your array or not. That's it. Fine. You're not concerned about how many copies of that particular value are present in the array. Clear? Yeah?
Yes, ma'am.
Fine. So we are coding for that particular problem, linear search problem. That is whether the element is present there or not present. So we are coding accordingly this way. If like take your case, take your problem statement. As you are saying, if we have 2 5s, like let's come back to your explanation. If you have 2 5s, then in this particular case, when we are not commenting on break, then it will print only the index value of first 5. When it encounters first 5, it will come out of this loop and just print you the index value of that 5. Right? It won't even search for other 5. And that is the search problem. Right? And for your concerns, as it is coming to many of your mind, okay, if we have multiple occurrence of a number, then that is not particularly a linear search problem. That is a problem like some problem for another version that you want to find in an array. You want to find this particular element present how many times. If you want to find like this particular element present how many times, then you have no option to use break. In that your concern case, when you want to find like you want to find for all the multiple occurrences of that element 2, then you have no option of using break. You have to execute the complete loop every time. Right? Because you can find the multiple occurrence only if you search the complete array. No? Right? See, look at this problem. The question is like, is there any student who has scored marks 25? Is the linear search problem. Right? The second reframing of the same question is, how many students have scored 25 marks? Right? That is like your problem. How many multiple occurrences of 25 occur in the array? Right? Simple? Okay. So am I clear with this approach?
Yes, ma'am.
Abhi, I just don't want, Abhi, for the first time, don't go on time complexity, but ideally you should try minimum usage of variables and minimum use, you need to code, once you will be good at coding, you need to code it in a way that it is very much time efficient. Has minimum time complexity, but time complexity you will understand, not part of this course. Okay? Okay. Now let's search for next term. That's very interesting. Next way of searching. For this I need a board actually. This is binary search. See, this is one way of searching. Clear? Now in linear search, what was the problem actually? If your element that you are searching is present at the very first 0th index, your algorithm is going to work like the best. It will search you in the minimal time, right? But if your element is present at the last index value, then you have to keep on searching every element of the array and then go to the last element. So it is in that particular case, that is like worst case scenario for the linear search, that you have to scan a complete array and in the last you will find it. Fine? That is analysis of linear search. Now let's go with binary search. Let's simply say how binary search works. Say we have this array. This array A0, A1, A2. I'll tell you very interesting part of this. This is very interesting. I'll give you next assignment question. A3. A5, sorry. And A6. Right? So we have an array of 7 elements. Right? Suppose same integer array of size 7. Right? Now, if we have values in here, let's say 10, 15, 17, 20, 22, 24, and 30. Fine. Just pay attention here. Binary search works only if your array is sorted. If you pay attention, we have this array is sorted, that is in ascending order. We have array in all the elements are in ascending order. So binary search we can use only on arrays that are sorted. That is the condition of using binary search. Right? Now, how binary search works? We'll analyze both linear search and binary search later, but first let's understand how binary search works. Right? See, this is the first element of the array, and this is the last element of the array. Is that okay? let's say L we are denoting the first element and U we are denoting the index value of the last element. So initially L is 0 and U is 6. We are just using these two variables to point to the first index value of the array and U to point to the last index value of the array. That's simple. Fine. Now, what do? We compute a mid value. Mid we compute as average value of L plus U. Do you understand this sign? Do you understand this sign? This we call as floor function. Floor function. Floor function means if here whatever you are computing, that is say coming out to be a value 2.5, then you will take a floor value. Floor is smallest integer, closest and smallest integer. Highest integer close to this value. Highest integer close to this value. What is the highest integer close to 2.5? Sorry dear, I have to reframe it. Integer value that is not a integer. Floor function works in a way, the integer value that is not greater than this value, not greater than this value, but highest and closest to this value. That simply means if we are like writing 3.2, I'm not getting how to frame it, 3.2, then the floor value of 3.2 will be 3. Fine. If I are writing like minus 5.2, then the floor value of minus 5.2 will be minus 6. Fine. Like on scale of this values, wherever you are pointing it, just the smallest to that a proper integer value, wherever you are pointing it. Fine. Am I clear? Fine. Okay. Now, simply, let's come back here now. We have an array. These are the index values. L is pointing to the starting index value. U is pointing to the last index value of array. And we'll be computing mid of L plus U by 2 is floor value. Fine. Like in this case, it will be 3.0. And so the floor value will also be 3 itself. Fine. 3 is actually what we want is, so U is pointing initially in the first case, you will be pointing at this index value and this element. Fine. Fine. U is actually an index value pointing to this element. Now, what we want to say is, suppose the key we want to search for, the value of key we want to search for is 22. Fine. Suppose the key we want to search for is 22. Simple. Then what will happen? We will see, okay, we'll check this value with the value at this index. Whatever, not U, sorry, mid it is. I'm sorry, mid. We'll check the key value at the mid index value in array. Fine. We say it is 20 and it is 22. Fine. What we are searching for is 22, and the value at the mid index value is 20. Fine. So what we want is, what we will do next is, we will search in array. From mid plus 1 to U. We will search for this value from mid plus 1 to U, not in this part. Why so? Because just pay attention, because we say our array is sorted already, and we will every time we'll just use the starting index value and last index value, and we'll compute the midpoint. And the mid index value will check whether the value we are searching is less than or greater than. If it is greater than, if it is equal, first case, if it is equal to this value, element is found. Your search is done. Work is done. Fine. Second case, if that value is greater than this value, then we will search next only in this part of array. because you see the array is sorted. If this value is greater than this value, that means is high probability if this value exists, it will be existing in these three elements. Definitely it is not going to be present in these three elements. Logic clear? Fine. And the third case, say if the value of key that you are searching is less than the value at the mid index value, then in that case you would have searched in this array. Because of course that's if the value is present, that would have been present in this part of array only. If the value would have been a smaller value. Fine. It just works on this logic. It works on just this logic. Fine. Now, like for this particular case we are discussing, when the value we are searching is 22, then we'll be searching in this part of array. That's our final area of consideration. Fine. And to search only in this part of array, in this particular case, what we will do, we will update L. Fine. We will update L. And how we will update after this point of time, after doing that checking with the value of A at mid, what we simply did, we checked whether the value of A at mid is equal to key or greater than key or less than key. Based on these three situations, if it was equal to key, you would have just printed that you found the value. You would have printed that you found the value and you will just exit. You need not to do anything else. Is that simple? Fine. That is what we discussed. Now, second case, if the value of key is less than this value. Let's take first this case, what we are considering. Our value of key is greater than the value of at mid, like this one. 22 is greater than 20. Then we will be searching only at this part. And to make logic to work only in this part, what we need to do is we need to update L. And how we will update L is, we'll set L to be equal to mid plus 1. Am I clear with this? And look here, the third case, if the value of key would have been smaller than the value of array at mid index, then we would have been searching in this part. So we had to update U to point to this element, right? We would have to point U to point to this index value, up to this element. So in that case, we would have updated U and we would have set U to be mid minus 1. Is that simple? Is that simple? I'm just repeating what I have done as of now quickly. The simplest first thing we did is we have an array and we stored, okay, what will be the smallest index, starting index value? What will be the last index value of array element? Fine. Then we computed the mid. Fine. Mid is like you are computing kind of midpoint of the array. Simply. Don't stress yourself. Just compute the midpoint of the array. Fine. This is like the midpoint of the array. Fine. Then what you want is, okay, we'll check with this value, the value we are searching. If we find the value right at this point, if it would have been 22 itself, our work has been done. The element is found and we'll just exit. We need not to recursively search further. We need not to search it further in next loops. Fine? Simple. Now, if it is not present here, then what should we do? That is the second thing. If it is not present here, then we will see whether this value is greater than the value we are searching or less than the value we are searching. Right? If we say if this value would have been greater than the value we have been searching, in let's take second case, if we would have been searching say 18, then this value would have been greater. So that means this value can only lie in this area. Only in these array elements, not in these, of course. Fine. So to search next smart thing is you search only in this area. Fine. And to search only in this area, we had to update u, and you would have updated as u is equal to u minus 1, just to point to this element. Right? And the third case, like this one, what we are considering now, that we are searching for a value which is greater than the value at midpoint, then we need to search only in this part of array. Right? To search only in this part of array, we want u to be updated, and we want now u to point to this element. Fine. And to do so, we update L to like L is equal to mid plus 1. Is that simple? Is that simple? Clear? So we did nothing big deal. We just use L and U to store the lowest index value, U to be the uppermost index value, and we are computing mid. Mid is the mid index value, mid element value. And we are just comparing whether the value is present in this, present at that very position, or present in this half, or present in another half. That is all. Fine. If it was present in another half, so we updated accordingly L value. If it was present in smaller, less value than this half, we would have updated U to be pointing here. That's it. Fine. So that is what we have done here. Simply, like in this particular case, what we are considering when value of k is 22. After this first iteration here, the value, now we are considering only array part at A at index value 4, A at index value 5, A at index value 6. We are only considering this array part, right? Which is here is 22, 24, and 30, right? And your L is pointing to this because L is 4 now, and your U is pointing to this index value because your value of U is 6. Am I clear with this point? Fine. Now we'll repeat this step. This first step is this one, just setting the L and U, computing mid, and again updating L or U or find the value. So L and U are automatically set from the previous step. So we'll be doing is compute mid value. Mid will be 6 plus 4 by 10. Sorry, 6 plus 4 by 2. So it is 5. Simple. 5. So it is 5. So this is our mid. Fine. We'll be doing again this check whether value at mid, that is 24, is equal to 22. No. So what should we do? Whether this 24 is greater than mid? Yes. Second case. So we will update U to be mid minus 1, that is 5 minus 1. So 4 in this case. After this, what will happen is, now we updated U to be 4, pointing the same element. So after this, next iteration, this was first iteration, second iteration. After this next iteration, we'll be left with the array part only A4, because you see now L and U both are pointing to the same element. The value for L and U both is 4. Am I good with this? Fine. And this value say 22. Fine. And again we compute mid. We'll follow the same these steps now. We followed the same steps here, and we'll follow those same steps here. We'll compute again. We'll compute mid. Mid is 4 plus 4 by 2. So it is again 4. Now mid is also pointing to the same element, right? Because we are left with an array of only size 1. Na? So now again this check will be performed. Value array element at index value mid, that is 22, is equal to key, that is 22. Yes. So in this case, we would have just printed that element is found. And we will stop going further recursively. This case is clear? This case is clear to everyone? Can I just change the question a little? I just want to change the search value. Suppose now the search value is 21. Take from the starting case. Take from the starting case. The search value is 21. Let's see up to which iterations you will go. Let's see up to which iterations you will go. Just follow the same logic. Now the search value is 21. Let's see, first iteration, you will tell me what will be the output after first iteration, what will be the output after second iteration, what will be the output after third iteration. Will you go for the fourth iteration or not? Right? This is, we understand iterations now, right? This is for first iteration, second iteration, third iteration, and you will tell me we will be going for fourth iteration or not. Let me see anyone. Okay, now see, you are doing something in yourself, okay? Now let's see here. Now look at here, when the value we are searching is 22, we are considering that case now, right? Now if we are searching for value to be 21, then the first case would be same. Initially the value of L would have been 0, U would have been 6, and mid we would have computed and come out with value 3. So it would have been pointing this element, right? Now we'll again check 20 is equal to 21. First case, no. So is 20 greater than 21? Second case, no. Is 20 less than 21? Yes, the third case is true. Fine. In third case, that means the element we are searching must be lying in this half. Logic clear, hai na? Why we are doing so? Because array is sorted at a one particular point we chose, and at this particular point we are saying the element we are searching is same or less than this or greater than this. If it is less than this, it must be lying in the first half. If it is greater than this, it must be lying in the second half, because all the elements greater to this are lying in its second half. That's the logic, right? So it is greater than 20, so it must be lying in the second half. Fine. So that means we need not to search the complete array. We just need to search in the second half. Fine. To search in the second half, we need to update L, like the third cases. We'll need to set L is equal to mid plus 1. We want L to be pointing to this element. Correct. So the second thing would have been same. We updated L to be 4, and U is again 6, and we again computed mid. The same thing. L and U are updated. Now we'll again compute mid. Fine. As we compute mid, we come up with a value 5. So mid is pointing this value. And we'll perform the same check again. Whether 24 is equal to 21? No. Whether 24 is greater than 21? Yes. This case is true. 24 is greater than 21. That means the search value should lie in this half, first half to this. right? So for that you need to update U, right? So again we want U to be pointing to this element. We updated U to be mid -1, fine. So U happen to be, after this execution, you happen to be pointing to, updated to 4, correct? Now, third iteration we go. In the third iteration, we start with only one element. U is also pointing to, value of U is also 4, value of L is also 4, U is also 4, both are pointing to the same element. Fine. The first thing we'll do again the same thing, compute the mid. 4 plus 4 by 2 will be 4 again. So mid is also the same element. Fine. Logically, mid we are doing is, whenever we are computing mid, we are just finding the mid value. Array size, we are just finding the midpoint of that array. That's it. Okay. Again, the midpoint is same when the element is 1 only. Now we check U is, array element at mid value, that is 22. 22 is equal to 21? No. Is 22 greater than 21? Yes. So this is the second case. We need to update U and set U to be mid -1. Fine. We need to set U to be mid -1. So that is 3 in this case. Fine. Fine. If your L is 4 and U is 3, fine, where we say ki L is pointing to the lowest index value in the array and U is pointing to the uppermost index value of the array, right? And when in this particular case we say your L is 4 and U is 3, in that case you say that you don't have any array to search for. Whenever your L is greater than U, whenever your L is greater than U, that is your stopping point. Because this scenario occurs only when you have scanned all the array and you didn't find the element and you have cross-boundaried it. Fine? You see in all the possible cases, L is less than U, L is less than U, L is less than or equal to U, L is less than or equal to U. Fine? Whenever L becomes greater than U, that means you have searched all possible values in the array and there is no possibility that the element is present in that. Fine? There is no possibility that the element is present in the array. Correct? So at this point, you will stop if this case occurs. Whenever you kept on searching and you find you ended up in a situation when your L is greater than U, then you will stop and simply print element is not found. That is your stopping point. Fine? Am I clear to everyone? Here in binary search, you will be stopped going in iterations only in 2 cases. First case, when you execute this situation. Like initially when we were searching for 22, in third iteration, we executed this situation, we printed element is found and we exit. Our work is done. Or second case, whenever your L goes greater than U, that means this L is pointing to the lowest index, U is pointing to the highest index, and they swap each other. Fine? Whenever this happens, that means you have searched all possible values and the element is no more there. So you stop. You need not to search further and just print element is not present. Fine? And need not to go for further iterations. Am I clear? Am I clear? So actually, binary search is doing what actually it is doing. Now try to analyze what it is doing. What actually binary search is doing, see, it is saying if you have an array of 10 elements, to search for a particular value, you need not to go to every element and search whether that value is present or not, present or not, present or not, present or not. From 0 to 9 indexes, you need not to search sequentially. The better it says, arrange these elements in sorted order. Okay? In ascending order, arrange these elements. And now If you find the midpoint, and if your search element is present at the midpoint, print that your value is present. You find it. That is the search problem statement. Na? You just need to find that value is present or not. That's it. Fine. If that is not present, compare whether this value, the value you are searching, is greater than the value at this midpoint. If so, that means you need to search only this second half of it. Because all the elements greater than this value at midpoint of the array are on the second half of this. You need not to go to search these elements because these are all smaller than this and your value you are searching is already greater than this. So definitely it would be lying somewhere here. Not here for sure. So you reduce your search space. Instead of complete array, in one iteration, you reduce your complete space to half the size of it. Right? And second iteration, again, you take the same thing. Instead of complete array of 10 elements, you just considered array of these 5 elements. And again, you computed the midpoint. Again, you compared it with the search element. If it was present there, your search was done. If it was not present there, again, you would do is, you will search. You will see whether this element is smaller than the mid value or greater than the mid value. If again it happened to be greater than the mid value, again the size of 5 you reduce to size of 2. Right? Again in the size of 2 you will compute the midpoint. You will check the value. Again you will search for less half or greater half. Either if it would have been present, size of may reduce to 1. You find it at array of size 1. If it was not again present, then you again, just going with the logic, you would have updated value of L and U, and that in that case, L would have been greater than U. And so that is the case that you need not to go further, element is not. That is the second case we did using value of search to be 21 in this array, which is not present here. Am I clear? Am I clear to everyone? Any query on this? Any query on this, dear? No? Any query? Anybody? Binary search clear hai? It is very important as conceptually. It is like in your BTech degree, first conceptual thing you are studying. Right? Now let's go to linear search. How we compare the two things. In linear search, if we go, what we do, we just start with, we need not to think much. We just start with index value 0, then index value 1, 2, 3, so on and so forth. Fine. In that, say in these kind of problem statements, when the solution could be at 0th index or at last index, we define like best case and worst case. Best case is when you execute, when in minimal steps you find the solution. That is the best case. Worst case is when in maximum number of steps you do and then you find the solution. That is worst case. Right? So in linear search, the best case is when you find the element you are searching for at 0th index. That means if you see in that case, the for loop you are executing, that you will execute only once and you will find your element. Right? So that would be the best case for linear search. Right? So time taken, or I just made talk in terms how many times the loop was executed was only once. Simple. Similarly, in the linear search, the worst case, that the maximum number of steps you have to execute, maximum number of times the loop has to execute. The worst case would be when the element you are searching for is present at the last index value in the array or not present. Both those cases will be the worst case. Because, why worst case? Because if the element was present at the last index value or not present at all, in both the cases you will be, the loop you will be executing for the number of times equal to the size of array. If the size of array is 5, so loop will be executed 5 times. If the size of array was 10, the loop will be executed for 10 times because you will be searching 0, 1, 2, so on to 8, 9. Every element you will be comparing. So you will be executing loop for every index value. Right? Best case or worst case समझ आया? Simple है? Fine. Okay. Now, in that we say that the execution time is directly proportional to big O of n. Size of array पे depend कर रहा है how much time you are taking to execute linear search. Right? But in binary search, the time or the number of comparisons you are doing is log to the base 2 of size of array. Try to do it. This many number of times you have to go for iteration. Log to the base 2 of size of n. That many maximum number of comparisons you will have to go for, or maximum number of iterations you have to go for. Right? Just take simple case. See, in binary search, the best case is when the search value is present at the midpoint. Right? Worst case is when the search value is either not present in the array or present at the first index value or last index value. That will be the worst case for binary search. Simple, right? And for that, in case of binary search, you will be going these log to the base 2, where n is the size of array. These many number of comparisons, I would say, or these many number of iterations. Okay? Simple. Now, just to give you a glimpse of how it is doing so. When we are comparing 22, right? 22, so we want the maximum we need to find whether 22 is present or not, 22 or 21, present or not. We need to go for maximum log to the base 2 of 7. Log to the base 2 of 7. If you compute this value, it will come out something to be 2 point something it comes out to. 2.8 or 2.7 it comes out to be. Achha, iska floor value. Ceiling value. Ceiling value of log to the base. 2.8 comparisons you have to make. 2.8 means 3. Ceiling value jab lenge, so it is 3. So maximum 3 iterations you have to go. And you can see, you could look for 22, you have to go 1 iteration, 2nd iteration, and 3rd iteration. That's it. 4th iteration, either we found the value at 3rd iteration, or after that we just for sure we say the ln view value has swapped and you are done with it. Am I clear? Am I clear with everyone? Right? Just keep this noted down. This time complexity, best case, worst case, I'm telling you right away. Maybe you are not so comfortable with it right away, and you need not to be very comfortable with it at this point of time. But this is how you should think and analyze for problems further. In this course, you just need to understand how the syntax is working, how the things are going, how to write the code. That's all. This much you understand is very good. If you don't, just do not panic about it. Right? Right? Simple, eh? So let's look for the code for binary search, and let me know if I need to explain anything about it. Just let me quickly tell you the key points so that we can wind up the lecture here then. So this is the main function, right? Okay, you may write here void or you may avoid. Both are correct. All right. We declared an array. We called binary search. We passed the array in it. Starting index value, that will be the L. Last index value U, and key is the search element. Right? Like here we write key to be 10. Right? So this is L. Initially it was set to be 0 from the value of actual parameters. R is set to be 4 and X is set to be equal to key, that is 10. Right? Then we look for L is less than equal to R. Why we are doing so? Because that would be the stopping condition, no? Because that binary search will stop only in 2 cases. One, when we find the element. Second, when L is not less than equal to R. Okay, R here you can use instead of R, U, so that you can just map to the same logic we discussed. L is U in this case. Right? Fine. This is just we formulated how to compute ceiling value of L plus R. So you can simply, instead of this, you can simply write it L plus U divided by 2. That will, by default, both our integers will give you the floor value. Right? Again, we did this thing. If you find it, you just return M, because at index M, the element would be found. Else, check value is less than key value. If so, update L. Else, update. Else, if भी लिखो तो it's by default it is same case. If M is greater than X, by default also it is the second case, or you may write it this way. Right? Then update R and keep doing this unless you exit through this point, which is the find element point, or your L becomes greater than you, and then you exit. Am I good with this? Am I good with this? Or you fine? Just try it once, then we'll discuss. Fine? Okay, we are good with this now?